if the function f of z belongs to star-like function with respect to symmetric points and is of the form f of z, then we have to prove that modulus of a2, a3, a4, etc. up to a7 values. Let us see how it works. In proof, for the function f of z, there exists an analytic function which should satisfy h of 0 equal to 1 and real of h of z greater than 0, such that this is a condition for star-like function with respect to symmetric points. After equating the equation between 2 and 4, you can see on the right hand side equation 2 and 4, we can easily get the value of a2, a3, etc. up to a7. And now to find the value of a2 and a3, we by using equation 5, that is zeta n modulus less than or equal to 2, we can easily find out the value of a2 and a3. Now to find out the value of a4, we have utilized here lemma 1. Taking the a4 value, here I am substituting the value of zeta 2 and zeta 3 here. And I am taking mod x equal to t. T belongs to here 0, 1 and zeta belongs to 0, 2. And also by applying triangular inequality, I will get the equation for mod a4. I am taking that equation as f of zeta, t. I am differentiating f with respect to t here. As this is an decreasing function, so the maximum value of f of zeta, t will occur at t is equal to 0. In the place of t, we have to substitute t is equal to 0. So I am taking this equation as I of zeta. I am differentiating I with respect to zeta here. By looking into this, it is an increasing function. So I am setting I dash of zeta equal to 0. So the maximum value of zeta will occur at zeta equal to 2 by 3. By substituting this in I of zeta, we will get the value for mod a4. Similarly, we can, by using this method and by using different lemma, we can find the value of mod a5, a6 and a7. Let us move on to theorem 2. If the function f of z belongs to star-like function with respect to symmetric points, then the fourth Hankel determinant for a3, a6 minus a4, a5 is less than or equal to 5 by 6. Here I am using different lemma here. So in proof, first let us substitute the value of a3, a6, a4 and a5. I am rewriting this equation in the form of lemma 2 so that I can substitute the values here. So after substituting the values here, I will get the equation for mod a3, a6 minus a4, a5. So I am taking that equation as I of zeta and I am differentiating I with respect to zeta here. So the function will reach its maximum at zeta equal to 2. So by substituting this in I of zeta, we will get the value for mod a3, a6 minus a4, a5. Similarly, in theorem 3, I have proof for mod a2, a5 minus a3, a4. With the help of lemma 1, lemma 2 and lemma 3, we can easily find out the value here by using these methods. Similarly, a3, a5 minus a4 square is less than or equal to 5 by 4. And the Hankel determinant for a2, a6 minus a3, a5 is less than or equal to 19 by 16. Similarly, in this way, I have found out theorem 6 and theorem 7. So let us move on to the last theorem here. If the function f of z belongs to star-like function with respect to symmetric points and is of the form f of z, then we have to prove h4 of 1, that is a fourth Hankel determinant for star-like function with respect to symmetric points is less than or equal to 16.20. In proof, I am taking the equation for h4 of 1. And here, after applying triangular inequality and the above theorem results, I will get the desired solution. By using this research, one can be able to find the similar bounds for different subclasses of analytic function. So this is my reference part. Thank you.
Thank you.
Yeah.
So, what methodology you are using in order to find the bounds?
I'm using star-like function here.
Okay.
Yeah.
So, any type of algorithm you are using or what?
No, I am using the lemmas like Libera, Ravichandra Verma. They have used, they have find out the different lemmas. I am utilizing this in my results.
Okay.
Yeah.
Oh, thank you. Thank you so much,
Thank
ma'am.
you. Thank you so much.
Thank you.
Thank you for giving me
Thank
this
you.
opportunity. Thank you.
See you. Thank you.
Bye.
So, V. Jaipuria,
Yes, sir.
you are there. Okay. So,
Okay, sir.
please share your screen.
Okay, sir. Good evening to all. To, I am Jaypriya from Tamil Nadu under guidance of Dr. N. Nityapriya ma'am. Today we will explore the basic concept of convolutional neural network and Eden-Margo model, the application and how they compare. This is my index. Next, introduction. Both convolution neural network and Eden-Margo model are used in machine learning, but for different tasks. Convolution neural network for image processing and Eden-Margo model for sequence like speaks and handwritten analyze. This presentation cover the concept, application, and key difference. Next, basic concept of convolutional neural network. Convolutional neural network are inspired by the human visual system, unlike traditional neural network that process entire images as flat inputs. Convolutional neural network preserve spectral relationship by applying filters to extract hierarchical features. The key idea is to detect patterns, example, edges, shapes, structure at different level and use them for classification or recognition. Why convolutional neural network for image processing? A traditional neural network struggle with high dimensional image data. Convolutional neural network reduce the number of parameters through convolutional and pooling operation. They automatically learn important features without manual feature extraction. The image represents the architecture of a convolutional neural network used for image classification. First, the input image of size 36 by 36 pixel. The first operation applied is a convolutional with a 9 by 9 filters, which extract the image size from the image size and convert it into pixel. Next,
Hello. Jaypriya. Hello. Hello. Okay. Jaypriya. Hello. Again left. Huh? Nice. Nice. Saraswati, and can you hear me? Please unmute yourself first.
Sir, are you audible?
Yeah, now you're audible. Yeah. Jaipriya, please continue.
Okay, sir.
So your screen is not visible. So
Okay, sir. Okay, sir.
yes, now it is visible. Continue.
Thank you, sir. Okay. Good evening to all. I am V. Jaipriya from Tamil Nadu under guidance of Dr. N. Nityapriya ma'am.
Hello.
Today,
Please
sir.
please continue when you have already 4 to 5 slides. I think you have already presented.
Okay, sir. Okay, sir.
From that you
Okay,
can
sir.
continue. Okay.
Okay, sir. So next convolution components, what is convolution layer? This is the core building block of convolution neural network. It applies filters to an input image, detecting patterns like edges and shapes. Each filter slides over the image and performs element-wise multiplication, producing a future map. This is the mathematical operation of convolution. X is input image, W for filters, B is bias, X dash for the output future maps. Next, what is happening in the image? The matrix on the left, the number represented fickle intensity of an image. The dark blue regions show the part being proceed. The middle matrix is the filter. This is the 3x3 filter, a small matrix used to extract features. The next right side matrix for the future map, the sum of multiple values is placed in a new matrix highlighting important features. The number 16 in the future map is the result of applying the filter to a part of the image. Next, activation function. Activation function most of used for ReLU activation function. ReLU activation function is nothing but it replaces all negative value with 0 while keeping positive values unchanged. ReLU activation function is defined maximum of 0 comma x. See the example. All negative values become a 0. The positive values not changed. ReLU function introduced non-linearity helping convolution neural network learn complex pattern, reduce the vanishing gradient problem, making training faster. Next, pulling layer, reduce the dimension of feature map while preserving key information, help in making the network invariant to small translation of the input. Maximum pulling, select the highest value in a region. See the example. The 4x4 image is divided into 2x2 region highlighted in the purple color. For each region, the maximum value is taken. For example, the first matrix 2x2, 7, 3, 8, 7. The maximum value is 8. Next, fully connected layer. Connect exact feature to final output classes. Work like a traditional neural network for classification. For example, see the picture. Convert a multi-dimensional future map into a 1D vector. Next, Eden-Margot model is a statistical model used to represent system that transition between Eden state over time with observable outcomes that depend on this state. Next, key components of a Eden-Margot model consist of 5 key components that define how a system transition between Eden state and generate observable outputs. The first first component is status is represented by capital S. These are the hidden variables of the model, meaning they are not directly observable. The system transition between these state over time. The notation is given by where n is the number of state. Next component for this observation, is represented by O. These are the observable outputs generated by the Eden state. Each state produces an observation based on a probability distribution. The rotation is given by where T is the length of the observation sequence. Next component, transition probability matrix, is represented by capital A. The probability of moving from one Eden state to another. Each entry Aij represents the probability of transition from state Si to state Sj. The notation is given by each row sum to 1. Next component, emission probability matrix, is denoted by capital B. The probability of an observation being generated from a given state. Each entry Pij represents the probability of observing simple Oj when in state S. The notation is given by next component, initial probability distribution, is defined by pi I. Specify the probability of starting in each state. Each entry pi I represents the probability of starting in state Si. Next, example of Eden-Margo model. Just imagine a person inside a room with no windows. They cannot see the weather, but they can guess it based on the friend's activities. If the friend is walking, shopping, or cleaning, we can infer whether it's sunny or rainy. The system has two Eden state. Rainy is S1, sunny is S2. This represent weather condition which are unknown to us. Next, transition probability is arrow between the state. The probability of moving from one state to another. For example, rainy to rain for 40 percentage, rainy to sunny for 60 percentage, sunny to sunny for 80 percentage, sunny to rainy for 20 percentage. Next, bottom circle in the image, walk, shop, clean for the friend's activity. This is the observation depend on the weather. If rainy, the person is likely to shop 40 percentage. If sunny, the person is likely to walk 60 percentage. Emission probability linked from state to observation. This show how likely an observation is given a Eden shade. For example, given it's rainy, the probability of the person walking is 10 percentage, shopping is 40 percentage, cleaning is 50 percentage. Next comparison, next how they differ convolution neural network and Eden-Margo model in terms of data type, processing, architecture, training, strength, and weakness. First, the data type of convolution neural network work with spectral data, image, video. For example,
Jaipriya,
sir,
you have two minutes more only. Huh?
sir?
You have 2 minutes more only.
Okay, sir. Okay. For example, recognition face in photos. But Eden-Margo model work with spectral data. For example, predicting the next word in speech recognition. Processing for convolution neural network use filter to detect pattern like edges and structure. But Eden-Margo model use probability to model sequence assuming the next state depend on the previous state. Next, architecture of convolution neural network as convolution layer, pulling layer, fully connected layer. But Eden-Margo model, Eden state, transition probability, emission probability. Training of a convolution neural network use back propagation and gradient descent for large data. But Eden-Margo models use probability based method like Baum-Wells theorem used for small data. Next is strength of convolution neural network. Extract architecture feature highly accurate, but Eden-Margo effective for sequence modeling and prediction. Weakness of CNN need a lot of labeled data, computational efficiency. But Eden-Margo model assume fixed probability, struggles with complex patterns. This is our my application for convolution neural network. For image classification, medical imaging, diagnosis, autonomous vehicles, natural language processing. This is my Eden-Margo model application for real life speech recognition, handwriting, and financial. Next, weather, climate prediction. finally, conclusion. Convolution neural network and Eden-Morgan model are fundamental model in machine learning, each suited for different type of data. CNN actually spectral feature extracting, making them indexable for image and pattern recognition. Eden-Morgan model are ideal for sequence data, allow effective model of speech, handwriting, and time series pattern. Understanding the difference and application enable better decision making when choosing the right model of AI-driven solution. Thank you. Thank you, sir.
Thank you so much. So you have told that your model has lot of applications. It is one application is in ADAS, right?
Yes, sir. Yes.
So can you elaborately just tell how it is effective in ADAS? Yeah?
Sir, so CN model, when you unlock your phone with Face ID, detect your face. But Eden Morgan model, when you use Google Voice, predict the next word in your sentence, sir. This is my best example for. Sir?
You have written there in
Sir?
that slide. In that slide, you have mentioned that it is applicable in the ADAS system. ADAS, the driver system. That which slide you have mentioned that? Third or fourth slides maybe. The last, but third or fourth slide. Some application part you have mentioned.
Yes,
So
sir.
I just want for curiosity that how it is, how your model is effective than other model in ADAS, especially in ADAS.
Especially Yadav.
It's okay. Thank you. Thank you,
Yes.
sir. We have okay. Thank you so
Okay.
much for presenting in this seminar. Okay.
Thank you, sir. Thank you, sir.
Thank you.
Okay. Oh, thank you.
Of this seminar. Okay.
Thank
Now we
you,
have
sir.
reached
Thank
that.
you.
Yeah. Thank you. Thank you so much. Saraswati N is
Yes,
also
sir.
from Tiruvallur University.
Yes, sir.
Yeah, Tamil Nadu. So,
Yes, sir.
so please share your screen.
Good evening to everyone. Sir, visible, sir?
Yes, yes, it is visible.
Okay. Good evening,
Just
everyone.
yeah, full screen
I
it,
am
please. Use the full screen mode there. So it is. Yeah. Now it is okay. Now it is okay.
Saraswati, research scholar, DKM College for Women, Vellore, Tamil Nadu, under the guidance of Dr. M. Kasturi, Assistant Professor, Research Supervisor, PG and Research Department of Mathematics, DKM College for Women, Vellore. The structure of the PPT is introduction, Bessel's equation, Bessel's function, modified Bessel's function, recurrence formula, orthogonality of Bessel's function, generating function for Jn of x, some examples, and then conclusions. Introduction. Bessel's functions have been known since 18th century when mathematicians and scientists started describing physical process through differential equations. Bessel's functions were first defined by Daniel Bernoulli and then generalized by Friedrich Willy Bessel. Bessel's functions are set of mathematical functions that are solution to the Bessel's differential equations. Bessel's function describes the radial part of vibrations of a circular membrane. Radial part of vibration. This is the picture of this. Next one is Frederick William Bessel. He was a first astronomer who determined reliable values for the distance from the sun to another star by the method of parallels. He got the Lalande Prize in 1811 and 1816. He got gold medal of Royal Astronomical Society in 1829 to 1841. Her research fields is astronomy, mathematics, and geodesy. He died at the age of 61 in Pune, Prussia. This is a picture of the William Frederick Bessel's equation. The second order differential equations, this is known as a Bessel's equation. The solution of this y equal to a into jn of x plus b into yn of x, where a and b are constants, and jn of x is the Bessel's function of first kind, and yn of x is the Bessel's function of second kind. This is then defined as jn of x, and yn of x is defined as this. The sum of the Bessel's function of first kind and second kind is the Hankel functions of first kind. Next one, the difference between the Bessel's function first kind and second kind is the Hankel functions of second kind. This is also called the Bessel's function of third kind. Bessel's function of first kind is also called as cylinder function or Newman functions. Next one is modified Bessel's function. This is an alternate form of the second order differential equations. Substitute x is equal to iz. The complete solution is y of x equal to c1 I v of x c2 I minus v of x for all v except v equal to 0 or positive integer. Y of x equal to c1 in of x plus c2 kn of x for n equal to 0 or positive integer, where iv of x is called the modified Bessel's function of first kind and kn of x is called the modified Bessel's function of second kind. The 6 formulas is called as recurrence formula, are very useful to solve with the questions. Next one, orthogonality property of Bessel's function. The orthogonality of Bessel's function is a property that states that certain Bessel's functions are orthogonal to each other over a given interval. Integral 0 to 1 x into jn of alpha x, jn of beta x dx equal to 0 if alpha is not equal to beta. Next, if alpha equal to beta, the orthogonal property is integral 0 to 1 x into jn of alpha x, jn of beta of x into dx equal to 1 by 2 jn plus 1 of alpha whole square, where alpha and beta are the roots of jn of x. This property is used in many mathematical applications, including Fourier Bessel series and separation of variables. One, consider the differential equation. This is homogeneous differential equations of second order, which is a natural extension of Bessel's function. This complete solution is w of p comma q comma r of z double sigma k equal to 0 minus r power k factorial gamma of p plus k plus q plus 1 divided by 2 x z by 2 whole power p plus 2q. If r equal to q equal to 1 in this equation, we obtain the famous Bessel's function of first kind of order p defined by. Next, if q equal to 1, r equal to minus 1 in equation 1, we obtain the modified Bessel's function of the first kind of order p. If r equal to minus 1, q equal to 1 in equation 1, we obtain the spherical Bessel's function jp of z. Next one is generating function of jn of z. The generating function of Bessel's function of integer order is w of z comma t. The generating function is important in the theory of Bessel's function. The generating function for Bessel's function of first kind jn of x. This is the generating function of the jn of x, or generating function of the Bessel's function. One example is the find the value of j minus 1 of x plus j1 of x. Using the recurrence relation, fourth one, for jn of x is 2n jn of x equal to x into jn minus 1 of jn minus 1 plus jn plus 1. Next, this x is another side, 2n divided by x into jn of x. Put n equal to 0, j minus 1 plus j1 of x equal to 0. These are the applications of Bessel's function: electromagnetic waves, heat conduction, optics, quantum mechanics, fluid dynamics, signal processing, seismology, acoustics. Next one is conclusion. Bessel's function play a crucial role in many engineering and physics applications. Understanding their properties and solutions helps in solving problems with cylindrical symmetry. Thank you.
Thank you.
Thank
Is there
you,
any
sir.
question? If that is not the case, let us thank the speaker once again. Thank you. ସାଉଣ୍ଡ କରିବନି ସାଉଣ୍ଡ କରିବନି
If you want to say something, please come here and you share your experience for this student.
It's a very good and pleasure experience for me to attend that I have attended the seminar. I take this opportunity first of all to thank the Department of Mathematics of Sambalpur University for arranging this type of seminar and producing opportunity for newcomers like me to learn a lot of things. So, and I especially thank to the convener Professor Rai sir for and all the department students for their hard work for making this seminar very fine and smooth. And as a newcomer, I have learned a lot from here. Once again, thanks to all.
Seminar actually started plan conduct workshop converted to national seminar. So all credit goes to Roy sir. Single-handedly, with the help of students, your support, it may not be possible to conduct the seminar technically and everything. And also I'm thankful that good expert institute from NIT and Niger, and we are again planning to invite few of them again very soon for another similar kind of things. Thank you, sir, and thank you all for your participation. National seminar. Respected Madam Niyar sir,
my dear colleagues and my dear participants and students. So it was a planning like this to make it a success, and because of your participation and cooperation, the result came to success. And I hope in future, if you will be interested for this type of events, particularly if you prefer that Sambalpur University Department of Mathematics is the best platform, then you are almost welcome to suggest to organize this type of seminar or conference in the department. And definitely your suggestion and approach will carry out in future. I hope all the best for this one. Second thing is, no doubt your participation is very important, otherwise you don't have any plan to conduct a seminar like this. So once again, thanks to all the participants of this seminar, and I must thank to our students, department students, for their cooperation. Wholeheartedly they have supported to make this program success. Thank you very much.
Good afternoon to all. So I must first thank Professor Rai for organizing this type of seminar. The most thing is that if the participants they are benefited, then it comes to the height. So I think the resource persons they have selected, they were all over from all over the world, from different institutions, and you must be benefited by them. In future, you can suggest something to do which will be very much beneficial to you. And for the success of this seminar, the wholehearted cooperation of the Banarasena, that is the students of this department, they are the main aspect of this organizing this seminar. At this point I recollect in 2006 I was organizing one conference, and then also in the department there were nobody. I was alone. Nia sir was in some leave due to some health ground, and the statistics department sirs they cooperated me, and with the help of my students only I organized that. So I must congratulate and give thanks from core of my heart to the students of this department. And so with this I thank you all, and in future such type of programs I hope will be organized and you will be benefited by them.
Good morning to all of you. This is the first time I am coming to the department, Sambalpur University, and I enjoyed a lot. We were supposed to attend the 2-day seminar, but due to some academic problem in our college, so we were able to attend the only 1 day. And thank you the university to conduct such type of programs, and hoping we will attend more in future. Thank you.
Good afternoon, everyone. Respected teachers and dear brothers and sisters. So it was very wonderful for me personally that I learned so many things that were unknown to me. So I again request sir to please continue what you are doing, and please bring great personalities like this. Thank you.
I want to express my deep gratitude to Professor P.K. Rai sir.
No, department. What is department?
Organize Department of Mathematics with my students from this conference. Thank you.
Anybody else, please?
Sir, Kisan. Hey, Hey, come. Tell. You can tell something. So, good afternoon to all. First thing is, जने पिला एंटायर गैदरिंग रू हमर तो बहुत कम पिला छथि जो माने आसीथिले बाहर जो माने भीतर अछन त दे नो आवर मेसेज जदि जने पिला एई प्रोग्राम द्वारा एक्साइटेड हे कि मैथमेटिक्स रे कैरियर परस्यू करिवो देन दिस प्रोग्राम इज सक्सेसफुल हम जदि एबे कहूछु भोजी भात आसबार भोजी भात यूट्यूब सार माने आसिले कहिले हमको शुणिया पे भल लागिला सत कथा है आम भल भाव जाचु जे जहाँ आम शुणिलु सबू आम भितर को पशिनी बाहर कौट हल हल हो नथिंग हैज एंटर्ड इनसाइड किंतु प्रकृत में जदि भितर को नहीं तुम मान भितर जड़े पिला आइदर नंबर थ्री हो लियाल जोरा हो से रिलेटेड हो कि कला तुम जो वृंदावन सारे पढ़ाऊले आसिक वृंदावन साहू हु इज ए प्रोफेसर नाइसर नाउ ही वाज ए प्रोडक्ट ऑफ कलाहांडी मैथमेटिक्स कैंप he got excited in mathematics in Kalahandi camp. There was a department organized a camp in Kalahandi to catch some students young. So what I want to tell that तुम माने समस्ते चेष्टा करो निजे मैथमेटिक्स परस्यू करिया पई बा अन्य जने के परस्यू करिया पई ताकू एक्साइट करिया पई either you become a catalyst to help somebody to do mathematics, motivate somebody, or you yourself do. Then only you will be successful. Thank you all for helping all of us because in spite of the NET exam and I think tomorrow is our first semester students exam. They came still to the year. So that takes their interest. We are all thankful and we are especially thankful to Professor Roy also and to organize this. Let us close it now. Certificate online
Okay, thank you so much.